Hello students, today we'll discuss the basic terms and types of retaining wall. Since before designing any retaining wall, it is necessary to understand the materials which can be provided for retaining wall, for the construction of retaining wall, different loads coming on the retaining wall. So here we'll see different types of retaining walls. Myself, Dr. Praveen Chandra Dhake, working as professor in KKO Institute of Engineering Education and Research, Nasik. Well, so what is retaining wall? Retaining wall is used for maintaining the ground surfaces at different elevations on either side of it. That means to maintain the profile of the soil, retaining walls are provided. Whenever embankments are involved in construction, retaining walls are usually necessary. So where are the applications? So here, provisions of retaining walls become necessary in the construction of hill roads, basement in the buildings, water reservoir, in preventive measures against soil erosion, in landscaping, etc. So there are many applications, and according to application, we have to consider the load coming on the retaining wall and also the materials which are to be used for the construction of retaining wall. Similarly, in the bridge work, the wing walls and the abutments. Abutment means the last pier of the bridge is called as abutment, and on both sides of the abutment, whatever the walls are provided, these walls are called as wing walls. So obviously the wing walls are subjected to lateral pressure, but along with this lateral pressure, the abutments also support the bridge. That means gravity load along with lateral force, for which we have to design these wing walls and abutments. Well, let's see some of the photographs of retaining walls. So here is the photograph of the roads in the hilly areas. So here on this side you will observe that is the retaining wall which is provided to support this road pavement. Now many times you will find retaining walls are also provided on this side to prevent the landsliding. Now in this case such type of walls are not provided, but in many ghat sections you will observe retaining walls are provided on both sides of the road. That means below the pavement level on the outer side and in the inner side above the road level. Such type of walls are normally constructed. Well, another application here is the retaining wall for the basement of the building. So here you can see this is the wall which is provided for basement of the building. So it may be one-story basement or two-story basement, but effectively retaining walls are provided or can be provided for the basement of the building. Another application here is the retaining wall for water reservoir. Now we'll observe this is the retaining wall where on one side the water is retained, on the other side the soil is retained. Obviously design is as a retaining wall only. So this is one application where RCC wall is provided. This is the application where stone masonry wall is provided. So again here on one side the swimming pool is provided and on the other side there is a soil embankment. Another application is for the preventive measures against soil erosion. Normally what happens along such a steep slope in the rainy season, because of that slope water gains tremendous velocity, and because of that velocity the soil particles get eroded. To prevent this erosion, what can we do? So we can control velocity of the water by constructing such type of small retaining walls. These retaining walls not only controls the velocity of the water but also allows water to percolate through this soil. Well, so hence here normal such type of retaining walls are provided. So here are some of the examples. Now when the slope is steep, so very close walls can be constructed, but here gentle slope is there. So here one retaining wall is provided, another some at distance 100 meter another retaining wall is provided. So here what are the available material is there, what are the available stones are there, okay, by using these retaining walls are provided. Here again another example. So this is the one wall, this is the second wall. So these are again the stones which are locally available, and easily such type of walls can be constructed to prevent the soil erosion. Well, another example of retaining wall, application of retaining wall is in the landscaping. Now here to achieve the level difference from this level to this level, because the house is constructed at this level, and to achieve this in the landscaping beautifully the wall is constructed. See how beautiful the wall is constructed. Now here one level, second level, third and fourth. So 4 retaining walls are constructed and with steps are provided. Okay, so very beautifully the application of retaining wall is given. Okay, another, this is called as terrace gardening. So in this terrace gardening, when the slope is steep, okay, so multiple retaining walls, one above the other, can be provided. And what happens now, when this is the retaining wall which is constructed at the bottommost level, at the top of this retaining wall, at some distance, another retaining wall starts. Okay, so step by step, the level, the flat surface of the soil is achieved. Okay, and in that flat surface, good gardening can be maintained. This gives us scope for providing gardening also. It prevents soil erosion also, and it adds beauty to the landscaping also. Yes, this is the application of retaining wall as a wing wall and abutment. So this is the bridge, and in this bridge, the supports, along with the support, the wing walls are provided. So this support as well as this wing wall, these are designed as retaining wall. This is another again application. It is for the river. Now on both sides again, the abutments or the supports, vertical supports, and the wing walls are provided, and which uh, supports the soil also and the bridge also. Let's see some of the important terms. Backfill. Now what is backfill? So it is the material retained or supported by the retaining wall is called backfill. So this backfill may have its top surface horizontal or inclined, because accordingly our calculation changes. Okay. Now this is the example where the backfill is horizontal. So when backfill is horizontal, obviously only a triangular pressure diagram we have to consider. Okay, where the base intensity is Ka, gamma, and Th. Later on we'll see. Okay, how do you get the pressure from such type of horizontal backfill? Well, when on this backfill, some load is provided. It may be due to road traffic, it may be due to railway, it may be due to some construction. So that is called as uniform surcharge. Okay. Well, so this is horizontal but provided some uniform load. So it is called as uniform surcharge. And if that backfill is having some slope at the top, it is called as inclined surcharge. Okay. So what is that surcharge? The position of the backfill lying above the horizontal plane at the elevation of the top of a wall is called surcharge, and this is surcharge, inclined surcharge, and this angle of inclination to the horizontal is called as beta, and that is called as surcharge angle. Okay, so obviously lateral pressure diagram changes. So this lateral pressure is drawn exactly at the back face of the retaining wall. Okay, and this lateral pressure diagram again here at angle beta, which is this base intensity is K, gamma, and 2h, but with an angle beta only. So these are basic terms. Well, now let's see types of retaining wall. So based on the method of achieving stability and based on their shapes, retaining walls can be classified into following types. There are four types. First one is gravity walls. Second one is cantilever retaining walls. Again, there are two types into cantilever retaining walls. First one is T shape and second one is L shape. The third type is counterfort retaining wall, and the last type is buttress retaining wall. Now one by one we'll see what are these types, okay, and where are the applications of such type of walls. So a very common type is gravity walls. These walls can be constructed in brick masonry, stone masonry, and plain cement concrete, or that means PCC. Well, the dimensions of the wall are so proportion that the self weight, that means dead load of the wall, provides required stability against the lateral thrust exerted by the backfill. The stress developed in the wall is very low, and these walls are so proportioned that no tension is developed anywhere, and the resultant of the forces remain within the middle third of the base. That means, since we don't provide any reinforcement in that one, so obviously the stress must be very less. Accordingly, you have to increase the dimensions of the gravity walls, and these walls are economical up to height 3 meter. Well, these are some of the photographs of gravity walls. So this is the stone masonry wall where the bottom width is quite higher and the top width is almost 450 mm, and here whatever the height we can observe, it is almost 3 meter. Now this is the another example of this gravity wall. We'll just find the difference that here this is the backfill side, yet the backfill is not provided here, but this is the backfill side where the face is exactly vertical on the backfill side, but here the vertical face is provided on the opposite side, that is on the front side, and the sloping face is provided on the backfill side. So this is another example of the gravity retaining wall constructed in stone masonry. Well, this is one more application of retaining wall. It's called as gabion retaining wall. Now this is the mortar free retaining wall. So all these stones are kept one above the other, but when you keep the stones one above the one above the other, obviously where is the bonding since the mortar is not used? Okay, so to achieve the stability here, the mesh is provided. So initially a box of mesh is kept, and in that the stones are arranged according to the size. Normally large size stones are at bottom and small size stones are at top, and in between the chips are inserted. Well, when multiple layers are provided here, like here this side photograph or in the bottommost photograph, okay, obviously the width of the bottommost box is higher, okay, and step by step it can be lower towards the top. So Gabin retaining wall is most economical type when the stones are available easily. Okay, because the sulfate of the stone is quite higher, and so available of the space and availability of the material. If it is possible, then Gabin retaining wall is always economical. Well, second type is cantilever retaining wall. This is the most common type of retaining wall. Okay, in this one, the vertical part is called as stem. The base slab is again divided into two parts. The part which is on the backfill side, it is called as heel. The part which is on the front side of the retaining wall, it is called as toe. And this is the backfill. Okay. Well, sometimes to increase resistance of backfill to sliding, a vertical projection is provided below the base slab, and that is called as shear key. So in fact there are three parts, and the shear key can be provided. That totally depends on the calculations, okay, for the check against sliding. So there are again two types, T shape or L shape. When space is not available on the front side, we can design L shape retaining wall also. Normally in L shape retaining wall two components are present, stem and heel slab only. Okay, all these components are designed as cantilever slabs, and hence the name cantilever retaining wall. So here is the photograph you will observe. Okay, so this is the toe slab which is on the front side, this is the heel slab exactly below the backfill, and this is the stem wall. Okay, some of the photographs of the RCC retaining wall, cantilever retaining wall. Well, in this one more point you have to remember: the stability of the wall is partially provided by sulfate of the earth, soil retained by the heel slab, and partially by the sulfate of the retaining wall. Well, this type of wall proves to be economical for moderate heights, say 6 to 7 meter. Okay. Well, so this is the slant portion of the retaining wall. This is another example of the cantilever retaining wall. Here is the toe slab. Sorry, here is the heel slab, and on this side there is a toe slab. So here is the example. Here again in this one, this is the toe slab, and on that side there is a heel slab. Okay. This is L-shaped retaining wall. So in L-shaped retaining wall, since only two components are present, stem and heel. Okay. Well, so this is again the L-shaped retaining wall. Obviously, though, this is the precast L-shaped retaining wall. In that different the precast elements, okay, these are cast in the factory, okay, and directly transported, and with the keys provided here, these are connected with each other. So these are some of the photographs here. L-shaped retaining wall also you can see, and here also T-shaped retaining walls. All these are the precast retaining walls. Okay. Next, third type is counterfort retaining wall. Now, when height of the backfill increases 6 to 7 meter, then cantilever retaining wall proves to be uneconomical. So in that case, we have to provide counterforts, and hence the retaining wall is called as counterfort retaining wall. Now in this type, the base slab as well as this stem of the wall span horizontally, just like one-way continuous slab. Okay, and when there is a one-way continuous slab, obviously it needs supports. So these supports are provided in the form of these brackets. So these brackets are called as counterforts. So these counterforts provide support to the stem wall also and to the base slab also. Now, these counterforts are provided on the backfill side. So here is the backfill. Okay, so on this side, the counterforts are provided. The spacing of the counterforts, this distance between these brackets, okay, may vary from 1/3 to 1/2 of the height of the wall. More the height of the wall, closer should be the spacing of the counterforts. Okay, it's obvious. Now, by virtue of the position of these counterforts, okay, these are subjected to tensile forces. See, now along on this stem wall, the force is acting away from the backfill, that means towards this side, okay, and on this base slab, because of heel slab, the force is acting towards the bottom side. Okay, let me show it here. Just a minute. Now this is the direction of the force, okay, for stem wall, and this is the direction of the force, okay, for the base slab. Now since both the forces are moving towards away from each other, the counter force are subjected to tensile forces. Okay, so these are some of the examples of counter force retaining wall. Okay, so these are the counter force. Okay, and this is the stem wall. This is the backfill side. This is again another example. These are the counter force. Okay, and this is the backfill side. Okay, buttress retaining wall. Now, buttress walls are identical to counter force retaining wall, with the main difference that the vertical brackets are known as buttresses, and these are provided on the opposite side. That means on the front side of the retaining wall. So this is the backfill side, and this is the front side of the retaining wall. Here are some of the photographs. This is the stone masonry buttresses. This is the brick masonry buttresses, which are provided on the front side. Okay. Well, now since the force acting on the backfill, okay, it is lateral force acting on the stem wall. Okay, it is on in this direction. Okay, and the toe slab, okay, it is subjected to vertical force. Okay, well, so this is the upward force and this is the lateral force, and since both the forces compresses, okay, and hence the buttresses are designed as a compression member. Okay, well, here now these buttresses act as supports, okay, for the stem wall for toe slab. In counter force retaining wall, it acts as support for heel slab and stem wall. Now here it is for stem wall and toe slab. Okay, so this is the last type of retaining wall, buttress retaining wall. Now all these four types, according to the requirement, according to the site condition, okay, according to availability of the material, we have to decide type of the retaining wall. Okay, now this is one more example of retaining wall, which is the hollow block retaining wall. Normally what happens, the sulfate of the retaining wall also provides stability. Now this sulfate not only provided by concrete, but we can provide some heavy material into these lightweight blocks. So these lightweight blocks can be constructed in the factory, okay, and these are the hollow blocks. So this can be erected with one above the other, okay. To keep it in position, such type of bars can be inserted, okay, and later on these holes, okay, this can be poured with the some heavy density material. Okay, well, these are such arranged that these blocks are one above the other, the hollow portion is one above the other, okay, and later on it is filled with the heavy density material. Okay, again this is another example in which the block size is a little bit the higher size blocks are used here. Okay, since the height is more, here height is less. So this is again the application of hollow block retaining wall. Okay. Okay, that's it for today's lecture. Okay, thank you very much. In the next lecture, we'll start with the failure patterns, okay, and the design considerations of retaining wall.